Yes, yeah. I said you might know some of these words from business or from economics. So appreciation and depreciation. Are those words Mark or Donald has used in class? They've used these words?
No.
Are you sure?
No.
Not really. Have you heard those words come out of their mouths before? No.
Depreciation, like depression, no.
Not depression, no. Yeah. Not as bad as that. Alright, so you haven't heard these words with Mark, are you sure?
Yeah.
Not at all.
Have you done balance sheets with Mark?
Yeah.
And you don't know the word depreciation?
No.
I should believe her, yes. Yeah. You know, in balance sheets you have things like assets, like equipment, machinery equipment, yeah? And you know that each year the value of this equipment decreases. Yeah, and this is called depreciation. So this is like a business cost. You know, if you buy equipment for 10,000 and next year it's only worth 8,000, it has depreciated by 2,000.
We haven't studied this in.
But you know the idea anyways. Like, has Mark ever talked about this in business, that you buy equipment and then later it's worth less on the balance sheet? Yeah. So this is called depreciation. So you can probably guess then what appreciation means.
Increase.
It's increase, yeah. So what would be an example of an asset that appreciates?
House.
A house, yeah. A house would appreciate in value. Anything else? Antiques, yes. So let's do depreciate. So equipment, cars, what else? There's something that everybody has here that depreciates very quickly.
Phones.
Phones, yeah. Phones depreciate so quickly. After 1 year, it's worthless nearly. Or maybe not 1 year, but after 2 years. And what about things that appreciate then? So we have a house, antiques, anything else that might appreciate?
Music is already things.
Appreciate, yes, indeed. What else? What did you say?
Music is already things like watches, like cars, things like
Ah, yeah, but something from business maybe. Business or economics. No? 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 Business? Any business examples? What about if you buy stocks? Company stocks? Company shares? For example, if you bought shares in Apple 20 years ago, will they be worth more or less today? Much more than 20 years ago. 20 years later. In maybe 20 years in the future, they'll be worth less. So shares can appreciate or depreciate. Yeah. So what we're going to have a look at today is just questions about this vocabulary and calculations. Okay. So just a little bit of vocabulary, maybe firstly with depreciation. So if you can write this down. So it's the rate of loss in value, or I suppose to be even clearer, it's usually the percentage rate of loss in value per year. So it's a type of percentage, a type of interest. For a business, a good example would be equipment. So, you know, a business maybe spends 200,000 euros on equipment, and then 1 year later it's not going to be worth 200,000. If they sell it, they won't get 200,000. In fact, they might only get 150,000. Okay, so how much of a loss is that in value? That's 50,000, right? The depreciation, I want to write D for short, that would be 50,000 over 200,000, which is 25%. So it's lost 25% of its value.
Why you don't do like minus 25%?
Because the word D suggests the minus already when we say depreciation. Yeah? So let's say that this happens every year. Every year it loses 25%. Okay? At some point the equipment will become so worthless that maybe you think about selling it. What would be a good time to sell equipment? When do you want, like, imagine you have a car. When's a good time to sell the car? Like, why or when would you sell a car? What would be a good reason to sell a car?
When it starts to corrosion.
Yeah. So what's, from a business point of view?
When it's not efficient.
Again, yeah, so give me the exact thing you're looking for from a business point of view.
Most half of them.
Could be half, or could be less than half, or more than half even. So you understand that each year you have to pay maintenance to repair the machine. Yeah? So what a lot of businesses do, like with your car, you know, if your car is only worth 500 euros and you need to get it fixed, and fixing it would cost 1,000 euros, would you spend 1,000 euros fixing a car worth 500 euros? Some might, if the car had personal meaning to you, but for a business, no, okay? So a business usually sells equipment when the cost to repair it becomes more than what the equipment is worth. It doesn't make sense then to keep it, okay? So maybe this company pays 10,000 euros a year to repair the equipment every year. So once the equipment is worth 10,000, they might as well sell it, okay? So we want to know how long until it's worth 10,000. So if you were to look at it as a GP problem, it starts off 200,000. Then after 1 year, it's 150,000. Then it loses 25% again. So do you have it there? What would it be after another year? It loses 120. 100 and. 100. What type of sequence is this actually? It's a GP sequence, and what are we multiplying by each time? 0.75. Or, if you want to think about it like this, or equals 1 minus 25%. Minus, because like you were saying, Malik, the decrease. And so we want to know when will it be worth 10,000. So the formula is the UN formula from GP. You remember it's A or power n minus 1. Okay, I'll give you a minute to solve this. You'll need to also use logs again. Okay, so I'll give you a minute to try and solve this, to find the n. Oh, that's just in my question. Like, I'm pretending that after 10,000 the company sells the machine. They don't care anymore. Okay, do we have an n value? So firstly we'll divide by the zeros. Cancel. So I get 0.05 equals 0.75 n minus 1. I'll put a log on both sides. Actually, you know what? I'm going to make my life a little bit easier by changing this into 0.75 n over 0.75. Because n minus 1. I'll bring this up here. You don't have to do that. I want to avoid using the calculator for as long as possible. So that would be 0.375, half of, no, another 0, 0, 0?
No, like a J.
375, like this, yeah. That equals 0.75 n. Okay, so now I put in the log here, the n comes down. I'll divide by log 0.75, so that's my answer. So what do I get exactly when I type that in? 11.41. So the question is, do we round up or do we round down? What makes more sense here? Could be down. If you round it up, then it means you wait 12 years. In the 12th year, it will be worth much less than 10,000, and you're paying more to repair it than what it's worth. So for me, it makes more sense to round down here, that the business should sell it after 11 years. Okay, I'll do another one now, a little bit more difficult maybe. So that's depreciation. Let's do one about appreciation. Can I scroll down? So maybe again a business buys a factory and it pays a lot of money for it. Maybe it pays, I don't know, 750,000 euros, and then 2 years later, the factory is worth more because maybe the government invested in a new railway or something near the factory. The factory is worth more. So for whatever reason, the factory is now worth 800,000 2 years later. So it's increased in value by I% each year, and this is called appreciation. I'll just write APP for short. So what I want you to try and do for me is calculate that percentage. And wait, before you do, remember this is over 2 years, not 1 year. Okay, so just be careful with that. Do you think you have an answer? Yeah? Do you remember that it was 2 years? Yeah. 1, 2, 3, 4, 5, 6, 7, 8. We're still missing Nina, actually. She's out of the country still. She's out. She's not in Ireland right now, right? Or no idea? Do you know? She's not in Dublin at the moment? Yeah, that's what I thought. Okay, yeah, it's finished? Yeah, so let's have a look. What's wrong, Albert? 2? Yeah. 3.1 and 3.4 are very different. What did you get, Remo?
8.125.
Oh, did you get, Malik? You're not sure now?
3.33.
What did you get? No? What did you get? 5? Was it close to 3? Okay, so nothing. 2 years later, it's worth 800,000. It was originally worth 750,000. It's increased by I%. How do you increase a number by I%? You multiply it by 1 plus I%. However, this happens 2 times. So squared here. Yeah, does this make sense? Yeah. So what I need to do is divide. So cancel. What's that? 16 over 15, I think. Yeah, okay, we'll go with, again, no calculator right now. So we're looking for I, so what should I do next? I'll do a square root next. So, square root 16 over 15 minus 1 equals I%. What do you get here, please, exactly, on the left? 1.0328. equals, oh, but without, with the minus 1, so it's 0 here, yeah? That equals I percent, so then I would equal 3.28%.
Oh, I did it differently.
Oh, that's fine. Did you get the same answer?
No.
Then it's not fine. So write this way down, okay? Can you see it all?
I get the difference divided by 750,000.
Yeah?
And divided by 2.
Nope.
The 2 years.
Doesn't work like that. Doesn't work like that. Has to be this way. Has to be this way. The reason it doesn't work like that is because by dividing by 2, you're saying that the change per year was the same, but it's not. The change in the second year will be more than the change in the first year, because after 1 year it's worth more, so the percentage will be a bigger change. So it should be close, but it won't be exactly right.
Yeah, it was close.
Yeah, but not exactly right. Yeah. Okay, so write this one down, please, and we'll do another one now. Okay. Yeah.
Could you go up just a bit?
Yeah. Can you see? There's another question. There's another question I want to do from yesterday that we didn't do, but it's a bit more difficult. So I'm thinking I'll do one more from this, and then the difficult one from yesterday, and then I'll let you try. Which one will I do? Okay, can I scroll down now, Remo? Yeah. You know what inflation is, don't you? Yeah? So is inflation appreciation or depreciation? If you think about it like this.
Appreciation.
No, it's not. It's depreciation. Because, yes, the money value. So if you have a euro today, is it worth more or less to you in a year's time? It's worth less to you. So the euro coin is depreciating in value.
For the price of the product.
Yeah, equivalently the price of the products are increasing, but it's more, the value of the money is decreasing really. Okay, so what's a normal depreciation percentage for money? I know it's different for each country. Brazil is quite high at the moment. What would be a normal percentage?
2%.
Something like 2% would be good. So if you have a euro today, in 1 year's time, it would be like having only 98 cents. So if this is €1 in today's money, in a year's time, this is a year, it will be like having 98 cents in today's money. So, for example, I don't know, like maybe today €1 will buy me a coffee, but in a year's time, €1 won't buy me a coffee. I could only buy something that was worth 98 cents a year ago. It loses its purchasing value. You talk about this with Donald, don't you? Purchasing value? Yeah. And 2% is actually, you know, this is ECB. Do you know ECB? European Central Bank. This is the ECB's goal. They want 2%. Okay, they don't want more than 2%. They don't want less than 2%. They want exactly 2%. So my question is, you have €1,000 and you keep it under your bed. There we go. In any case, this is for added effect. But of course, this is stupid because it's losing value each year. By just sitting there, you're not getting more money. You're getting less money, really. So my question is, after 10 years, you forgot about the money. And when you were making your bed one day, you saw it under there. You said, oh yeah, I put money under there. So I want to know in 10 years' time, what will be the purchasing power of your money under the bed? That's what I want you to calculate, okay? 10 years' time, what is its purchasing power in today's terms?
2% inflation.
2% inflation. Or I should really say 2% depreciation.
How many?
10 years, €1,000.
Yeah.
It's bad, isn't it?
Yeah. So,
Yeah. So I think you've realised what you need to do. It's 1,000 times 0.8 power 10, and you get 817. Now it's actually worse than that. Why is it worse than that?
because it changes every year.
No, why is it worse than 817? Like, that's pretty bad. You know, it's like a mouse came along and ate nearly €200 of your money under the bed, right? So, but it's actually worse than that. Why is it worse than that? There's, again, something from economics. Make Donald happy, come on. Why is it worse than this?
Because if you put in a bank,
Yeah?
would
Yes?
appreciate
Yes? So what is this called in economics?
interest rate.
That's not what I'm thinking.
Real.
No. So there's actually a big opportunity cost. You could have put this in the bank. This was your next best alternative, was to put it in the bank. And you would have increased in value. Okay, so the bank would give you at least more than 2%. If the bank gave you 2%, then all that would happen is that your money would stay the same in its value. Hey, come on. I'm teaching you some economics here, yeah? The depreciation is 2%. If the bank offered you 2%, all that would happen is the purchasing power would stay the same. That the bank's 2% cancels the depreciation of 2% and they stay the same. So when it comes to purchasing power, you don't care what the interest rate is, you don't care what the depreciation rate is, you only care about the difference. So if the bank gives you 3% and the depreciation is 2%, you only care that there's a 1% difference.
The real.
This is the real interest rate.
The money is under your bed, it's not in the bank.
Correct. But we want to calculate the opportunity cost. So if he put it into the bank at 3%, what's the real rate? It's really 1% because there's a depreciation of 2% per year. So after 10 years, what's the purchasing power now? So do you use PP for purchasing power in economics? Or you don't have any special letter for it? No? Well, we'll go with PP. So PP if it's under the, very mature. PP if it's under the bed. So give me the purchasing power if it's in the bank now. So that would be 1,001 power 10, which would be, what is it? Yeah. 1,104. Yeah. So the opportunity cost, OC, 1104 minus 817. So what was your opportunity cost here? How much did you forego by choosing the bed over the bank? 287. That's a big opportunity cost. By choosing the bed instead of the bank, you have foregone €287 purchasing power. That's a lot. Don't keep your money under the bed, is the point. Right?
But if inflation is like 12.
Well, no, this is the other thing, yes. And also depends what the bank is offering as well.
Actually more than 2%.
What's more than 2%?
Interest rate.
Oh no, I think most banks in Europe are looking at around about 3%. Unless you buy something, special long-term savings, most banks are 3%. Yeah, you're not going to do much better than 3% at the moment. What's it in Brazil? Interest rate in a bank. Inflation is 12%.
12%.
So you need the bank to offer at least 12%. Probably not. No. So in that case, you're better off putting your money in something like gold or silver, something fixed value like this. Or spend everything. Also true. Yes. No. That is true. That is true. That's true. Or property. Yes.
It's better than.
Colum, the biology teacher, had a friend, and when they retired, they got something like, I don't know, they got 100,000 euros from their retirement, and they had a choice. They were thinking, okay, maybe we can put it into shares in the bank that they used to work at, or maybe they could buy a camper van? Do you know these? People drive around in them, they sleep in the back. Yeah. So they said, this would be the right thing to do, but no, let's do it. Let's buy the camper van. And then the next year, this was 2007, so then the next year, the shares in the bank, this was Irish Bank, the shares were 20 euros per share, and they dropped in value to 20 cents per share. So I know people who had shares in Irish banks, and when it goes from this to this, it's basically gone to zero. You've lost all your money. The camper van, however, after 1 year was still worth 80,000. So they had a choice of either depreciation by 100% or depreciation by 20%. So they made the right choice. So yes, spending all the money before it loses its value is one way to do it. Okay, there's one more example I want to do from yesterday, but it's a little bit difficult. So I'll break it up in parts, okay? We have a bank and it's offering 3% APR compounded monthly. Will be quite generous of the bank. And what's wrong? Question? Yeah. Is it about camper vans?
No.
I can't personally recommend any camper vans if that's what you're looking for. Is it about this?
No.
No, what is it?
This.
Huh? No, it wasn't. This story wasn't about me, if that's what you're thinking about. It wasn't like I bought a camper van. I promise you I don't have 100,000. Promise you. Right. 3% APR compounded monthly, and let's say you save 100 euros per month for 10 years. So the question is, after 10 years, how much money do you have in the bank? So this one is a little bit difficult because the money is increasing from interest rate, but also you're putting more money in. Also, what's making it more difficult is the money you put in at the start gets more interest than the money you put in at the end. So the first thing we need to do is, what is the interest rate per month? So if we do, here's the answer now. 3% divided by 12 is 0.25. So that means the 1 plus I% will equal 1.0025. Yeah. This is how much it increases by each month. So the first 100 euros you put into the bank, and just to make it clearer, we put the money in at the start of the month, and the bank pays the interest at the end of the month. I'll say that again. We put the money in at the start of the month, and the bank pays at the end of the month. Okay. So the first 100 euros we put in the bank, how many months is that sitting in the bank? How many months? 120 months, because it's 10 years and 12 months in a year. So that first 100 euros, it increases in value 120 times. Because that 100 euros we put in at the start, it sits in the bank for 120 months. Each month it increases in value by 1.0025. Yeah. Now the next 100 euros we put into the bank, it doesn't sit in the bank as long. How long does it sit in the bank for? 119 months, etc., etc., etc. The last 100 euros, how long does that sit in the bank? Just 1 month. So the total,
You took the money out or what?
no, you put 100 euros in each month and you leave it there. So the 100 euros at the start has more time to increase in value than the 100 euros at the end. That's why this one here would be much bigger than this one here. How much money you have all together, you add all of these together. Yeah? Question? Don't be shy. No, ask me a question.
You have to do it for each month.
Yeah, you have to think about this as, imagine your 100 euros, you put it into the bank, and that 100 euros increases 120 times. And then next month you put in another 100 euros, and that 100 euros increases 119 times. Then you put in another 100 euros, that increases 118 times. The money you have is all of this together. Yeah? Can you tell me, we'll start with the smallest one. So the smallest one here at the bottom, what is that? 100.25, is it? Yeah. And what would be the next one, which would have a square in it? So the next one would be, if you multiply by 1.0025, again, the next one up is a square. Yeah, times the last one by 1.0025. What do you get? 100.5. Okay, etc. Yeah. In fact, when you think about it, this problem is what type of problem? It's a GP problem, isn't it?
Yeah.
Where the A is 100.25, the OR is 1.0025, and the N is 120.
But in the first, the start of the month you put 100.
Mm-hmm.
So then the A is 100.
No,
But A
see,
is not-
I said you pay 100 at the start, but the bank pays interest at the end. So you always get interest because you're always paying at the start and the interest is paid at the end, you'll always get interest. Now, you're right, if you put money in at the end of the month and the bank pays interest at the end, then the last 100 euros you put in, there's no interest in it. And yes, in that case you would start at 100. Yeah. And that is important, But usually in the exam questions they keep it that you pay at the start of the month and you get interest at the end of the month. Yeah. Okay, so what formula do we need here for this GP? We're looking for S 120. So that would be N over 2, 2A plus N minus 1D. Okay, calculate that please.
No, it's
It's
AB.
Psi. Thank you. A, 1 minus or N over 1 minus or. There we go. What do we get here? Try to stay awake, Albert. Come on. Do you need some Red Bull?
Why is 0 when you it's power 120?
Huh?
The result is 0.
It's nearly 0, I guess, then. What did you get here? Did you get an answer? Let me check too. A is 100.25. What answer did you get? Did you get an answer? Negative. Nice. Not negative though. Did anyone get a positive answer? What did you get?
1.4
No.
Negative 35.
No. You mean 14,000? You all know how to use a 14,000
Nine.
Nine.
Yeah, okay.
euros.
14,000.
Yes. What did you do wrong, Junwei?
The RH calculates 0.0035.
Gotcha. Did you get it, Malik? I just typed the numbers in. So, what the A is 100.25, the OR is 1.0025, and the N is 120. You're using that old calculator. You haven't got the Casio one. Now, so you have to use brackets on that calculator.
Yeah, I did.
Yeah? Bring it over, let me have a look.
Oh, yeah.
Did you get it now? Bring it over, let me have a look. Is it still typed on the screen? Oh, it's cleared, it's gone now. Oh, never mind. Please buy this Casio one, it's so much easier to use. What's wrong? Is it okay? Now tell me, if he didn't put the money in the bank, if he just kept the cash, 100 euros for 120 months, what would that be? That'd be 12000. 12,000. So how much interest did the bank pay? The total interest payment was 2,009 euros, which is great. However, in Ireland we have a tax on interest, so he won't get all of that money. It's terrible. It's terrible. It's nearly 50%. It's terrible.
Is that like a tax on transaction?
No, tax on interest earned. It's
They already paid.
the tax. The name of the tax is called DIRT, Deposit Interest Retention Tax. So yeah, I know. So whenever you earn interest, the government will take about half of it. Yeah.
But people, I think, they already paid a part of that money. But it's their income tax.
Correct, yeah. So you work hard, you pay tax on your income, you save your money, you pay tax again on your savings, then you spend your money and you pay tax again on the VAT. You notice a recurring idea here, yes? Government, yes. Okay, so this one here, 2009. Now, I look away for 10 seconds and the three of you have your phones out. Put your phones away. They're too, no, that's too easy to take it out. Away. Turn it off, actually. Take the phone back out. Out, take it out. Show me you turning it off. I want to see it powering down. The three of you. Yeah, show me it going off. I want to see it powering down. Turn, let me see. Show me. Yeah, okay. It's either that or I take it. Which would you prefer? Albert. Right. You have a few minutes, do you? No, you don't. Okay. Wait.
Yeah.
Wait. Now, again, I want you to try. No. You're doing that thing where you're pretending you're listening, but you're not, because right now you're thinking lunch. So just, all right. What do you have now? So you're thinking economics. I want you to try all of those at home, because again, it's a new topic, okay? And you can talk to Stonewall about it. You can say that you've done appreciation and depreciation as well. Tomorrow we'll have a little bit of revision on what we've done so far, okay? So I'll print out some past exams, and we'll talk about coursework on Thursday.
And you set it on Thursday?
Yeah, I think so, yeah. I'll set it on Thursday, yeah. So I'll give you the date it's due on Thursday. Are you in this room or a different room? D07, okay. Light, please, Tony. Thank you. Arya.
You are done for today.
I've got some other things to do, so not quite done.
See you.
See you.
It's not just for September, so it's anymore.
True, but I still have stuff to do for September, like correct their exams and things.